Previously on Flatlanders.
So science doesn't have evidence that the Earth rotates?
Coriolis was never applied during my whole military career at all.
Are you really sitting down with this mathematical formula and figuring out what you got to do in the heat of battle? The answer is no. It just doesn't exist. There's no such thing as Coriolis.
When you fly forward for 69 miles, you will drop your nose by 1 degree. The problem is the gyroscope never registers that.
If the radar can see it, the Earth is not a ball, period. End of story. And does that happen very often? 1,000 times plus a day.
And knowing also that we were dealing with 6 gigahertz microwave, there is no way at all that these signals could have possibly propagated, but they did.
We don't have evidence that there's a curve.
There is no measurable curvature. So if there's no curvature, then we're not dealing with a ball, because you have to have curvature for a ball.
Science should never, ever be worried about investigating the flat Earth. I mean, science should welcome an investigation of the flat Earth. Science is supposed to be objective, to learn, to grow. And it's, as we are finding out, flat earthers are pointing out things about science that science doesn't have an answer for, and yet they still fight it. And I think the cover-up is a big one for me.
I'm sorry to cut you off. I only have a minute and a half, and I don't really need to hear what you're trying to provide. I want to know how you're dealing with all these conspiracy theorists on your platform.
So the first way is by demoting low-quality content and promoting more authoritative content, and the second is by providing more transparency for users, such as searching for "the Earth is flat" on YouTube, where you see a lot of
Your response is to put a box saying, "Nope, the Earth is not flat."
Correct.
Okay.
Are you listening now? Do I have your attention? Can I get a response to all the questions hanging in my head? Did you think I would follow? Did you think I would kneel? Because I want all the world to know exactly how I feel. You can't stop me. You can't stop me. You can't stop me. Can't stop till you know how I feel. You can't stop me. You can't stop me. You can't stop me. Now I got your attention. Now you know exactly how I feel. Can't stop me. Can't stop me.
We're 18 miles away from the Idaho side. We're on the south side, on the Utah side. So now we're going to shoot some lasers, see if we can see the other side.
I went to a reservoir in northern Utah, and for this test, my wife stood at the opposite end of the reservoir, and I had my camera at about 2.5 feet, and I had the P900 out, And she took a mirror from the top of the beach and just walked down. And I spoke to her on the cell phone as I filmed her, and she placed the mirror in the water, and she should have been hidden by 12 feet.
I was not a flat earther at this time, but purchased a Nikon P900, like many others, to see it for myself because I was incredulous, wondering whether flat earthers were faking their experiments. I conducted this test at Willard Bay, Utah on April 16, 2016. I chose this location because my brother claimed to have seen the curvature at this exact reservoir. For the test, I had my wife, at sunset, take a 4-foot mirror and place it in the water at the opposite end of the reservoir. And I filmed the entire thing from 6.3 miles away with a camera height of 32 inches. The 4-foot mirror should have been entirely hidden below the horizon with a target hidden height of 12 feet. These are the official numbers of how much should be hidden by the curvature. This isn't some fake flat earth math. These numbers have been confirmed by engineering software like AutoCAD as well. You can do the math yourself. It's not 8 inches per mile. It's 8 inches per mile squared. You just need to subtract the alleged globe distance to the horizon first.
And it was that time that I started calling myself a flat earther. Before that, I hadn't ever seen it. I actually thought maybe the flat earthers were faking it, but I saw it with my own eyes, and that water was flat.
Sorry, my globe faithful, this is not a mirage.
We got inspired to do the Chicago skyline test that we did across Lake Michigan after Joshua Nowicki snapped a picture of the Chicago skyline from, it was like 60 miles away or something like that. And of course we all saw it, and the weatherman himself said, of course, it's not possible to see that, so what you're seeing here is a mirage.
This photo from Grand Mere State Park, this is from Joshua Nowicki, and what you're seeing here is a mirage. We typically would not be able to see this from the Lake Michigan shore. We talked about this last night. Conditions are right on the lake that we're actually seeing a mirage of the Chicago skyline.
Anybody that looks at that picture, I mean, if you have half a brain, you should be saying, that's not a mirage. Mirages are upside down, wavy and distorted. This was all right side up. Now there's a little bit of stretching, but it was pretty symmetrical, straight up and down. And I'm talking to Rick about it, and it was in your market, wasn't it?
Yeah, I actually saw it live. That's the crazy part, is I actually was watching TV that night and it came on. I'm like, no way. I grew up seeing it that way. It's right in our market. I grew up about under half an hour to get to the shoreline, so it depends on the day. You can't see Chicago every day. You can't. I mean, it's impossible because humidity plays a part in it. Any type of particulate in the air is going to play a part of it at 50 miles, 40 miles across, 60 miles across especially, so yeah.
I'm like, Rick, I mean, this is about as simple as it gets, right? I mean, let's just charter a boat and drive across the lake toward the city. If it's a mirage, then my thinking was, well, if it's a mirage, it's going to magically disappear and then the city's going to roll up over the ball and there it is. If it's not a mirage, then the city's just going to get bigger and bigger and bigger in the camera.
As we get there, yeah.
I mean, it was about as simple as it could get, right, for a test.
The boat was the perfect idea because you should be able to see, like you said, all the way across.
And it was a perfect day. We couldn't have asked for anything better. I mean, we pull out of the dock and we turn, there's like an alcove there, and then you can go out into the lake. And we come out of the docking area, go into this little alcove area, and I looked across without the camera, without anything, and I could see Chicago just with my eyes.
Yeah.
I'm like, dude.
And I was watching Rob's
I
was watching him because I wanted to see your expression.
The city's right there, How perfect is that, right? So we started trying to shoot, but with like the Coolpix P900, that thing can really reach out. I mean, it can zoom all the way across. But the problem is we're on a boat that's doing this.
Yeah.
So trying to focus at that distance when we're doing this, it was
we're
like
trying to become a gimbal.
Yeah, we didn't have gimbals, so we were doing the best we could. But best I ended up doing in editing was just capturing a freeze frame. Okay. You want to just sit out? Okay. All right, we're good. Whatever we need.
What do you think, Skiba?
I think it's amazing, dude. It certainly did. It's not a mirage, I can tell you that.
Now, when you and I first started talking, and you brought this up to me, and I said, oh yeah, I can see Chicago across Lake Michigan. Do you remember what you said?
I don't remember what I said.
You went, no way. You said, no way.
Yeah.
I said, yeah, you can see all the way across.
seen it, and it ain't a mirage.
Not a mirage.
This is a rough draft. Obviously, it's very bouncy, but this is still, we're documenting this to show that it really does exist, and it's not a mirage. It's the proof right here. That's the proof.
Absolutely. And we've been recording the entire time, never losing sight of the city. But one of the things that I can say is that we do know for a fact that there was a bluish haze above the water that was at least somewhere between 8 miles out and the city itself. And that haze actually cut off the bottom of the buildings at the same exact line that you can't see from the beach in New Buffalo. The plan is to do another laser test, hopefully soon. I want to really see if I can get Bear Lake frozen and shoot a laser across it. That would be awesome. That'd be 18 miles, and I would love to do it over ice.
And so I'm going to go ahead and get some temperature reading of the water. And I'm showing 32.9, 32.8, 32.7. Just a little bit above freezing. So I don't think they any.
It's locked on, right?
What?
Let's get it right here. Let's get it actually.
Oh, okay.
Okay. Okay, good. Okay, there you are.
There you go.
Atmosphere or not. It seems like we're looking at some weather, exactly. Okay.
There, I see him. I see it.
Got it?
Yeah, I got it.
Did you see it in the thing, the source?
I can see it. Yeah.
Really?
Oh, nice.
World Health Organization, the UN, their logo and flag is the Flat Earth map.
It's really good.
Yeah, the concept of this globe that we've been indoctrinated with since all of us were young. One of the first things we all knew in the classroom was a globe. This is very interesting. Go YouTube the history of universal pictures. Back from 1912, when they first introduced the globe into their iconic logo and introduction to their movies, you can see the rhythm and the change of, they knew exactly what this globe looked like. NASA, the Apollo missions, everybody knows those, we supposedly went to the moon in 1969. You'd think we'd have a ton of pictures of the Earth from space from that very first trip to the moon. You know where the first globe picture came from? The very last mission in the year 1972 was the first that we all know as the Blue Marble. They didn't think on the first 5 trips to the moon to take one picture of this iconic globe. You got to ask yourself why that is.
Well, what about that picture that they show us? Where
Well, wait, why? Sorry.
Yeah.
Well, why?
They didn't. Yeah, why didn't we see one picture of the globe, the full picture of a spinning globe from space? Because it's too easy to debunk if they do it wrong. And it is.
I'm Paul Lindbergh. I'm an intellectual property consultant. Flat Earth matters because the truth matters. Meet a lot of people and talk to a lot of people about this subject, and unfortunately sometimes it doesn't seem to matter to them, and I just don't know if the truth matters to them. You know, whatever it is, the subject that we're discussing, you know, if truth is involved, I think it should be important, because that's what we should be concerning ourselves with. What is the truth? Well, the biggest proof that NASA is faking the round Earth would be the images that we get of the Earth from space. That's what I've spent a lot of man-hours showing and putting together videos around as, these supposedly a couple of satellites that give us these Earth images every 10 minutes or half an hour or what have you, that they're all CGI. If the Earth is a globe floating and flying through space, then we would have real photographs of the Earth. Those images that we get are anything but photographs. They're CGI composites. They're made on a computer. They're made in software. I think that NASA is faking it using, pretty sophisticated software. High altitude balloon footage, maybe, high altitude planes to take pictures, things like Google Earth, what have you, are going to, give us high altitude shots of what the ground looks like. But beyond that, those are all stitched together and put on a sphere. When people look at that, it kind of gets reinforced that we live on this sphere. Probably a classic example is Blue Marble 2.0. They even admitted they took these flat maps as stripped data, and wrapped it around a ball and then had to Photoshop in the clouds.
You guys know this story. You guys have heard of Robert Simon, right? The NASA data visualizer, right? I believe that's his title. And he even said that this is not a photograph. It's built in Photoshop by a digital painter. And in fact, he called it a sophisticated visualization. And certainly a callback, obviously, to the 1972 original Blue Marble that I believe is a painting. And this obviously would be considered a digital painting. And there he is, Mr. Blue Marble 2.0.
To us, the really cool thing was the data set. Up until that point, there was no realistic color map of the globe anywhere.
So the land layer here comes from
the moderate resolution imaging spectroradiometer aboard Terra.
And the tricky part here was the weather.
So we actually had to take clouds out.
They stashed the clouds for later, went onto the ocean. That came from an instrument that measures phytoplankton in the sea.
Where it was low, I colored it dark blue because they're low mostly in mid-oceans. And then where it was a little bit higher, it was like a little bit brighter green.
Then add the clouds back in.
There's a small problem with it because there's a very slight gap in between each orbit.
So some of those are painted on.
It is photoshopped, but it's has to be.
Then
there was another layer to sort of simulate the atmosphere.
And then there's this little bright spot.
It's called the specular highlight. So it's the reflection of sunlight off of water.
Those are the pieces, but you can't just slap them all together.
It just didn't look realistic. It looks kind of flat, or the clouds are sort of too see-through. So I just hit Command Z a lot.
There's artistry to creating the world.
And what was really interesting, I thought, was as I was investigating this guy and just learning more about him, this is what's on the NASA website, is that he was going through, this is kind of like a little bio or something like that, and talking obviously about his creation, this Blue Marble. And it goes through and he says, kind of how they made that. And then he said the hard part was creating a flat map of the Earth's surface with 4 months of satellite data. And he mentions this guy or lady, Rito Stockley, did much of this work. And then he says, then we wrapped the flat map around a ball. Fair enough. So, they obviously, as many of us have already learned, they admit that Blue Marble 2.0 isn't a photograph of the Earth, it's a digital composite. I also found it interesting in learning more about Robert Simon was an article, and this was from, and I don't remember the exact date, it was shortly thereafter the Blue Marble was created. But the title of the article was, "The Guy Who Created iPhone's Earth Image Explains Why He Needs to Fake It." And it goes through and quotes him, and at this point of this article it says, it's simply a background of black color that Simon placed the Earth on top of. The black area around the Earth is not the void of space. It is simply a background of black color that Simon placed the Earth on top of. This is standard practice, Simon says. Most actual, quote-unquote, photographs of the Earth, including the Apollo images, present the planet on a black background. So my question was, what is the scientific value if all of these things are admittedly manipulated? Why would they take a picture of something and not just show us the picture? Why do they have to cut out the Earth and put it on a black background? I mean, I don't know. Maybe that's just me, but I just find that really odd. Why don't we just see the picture you snapped? Why do we have to have all this post-processing or manipulation?
Even that picture in 1972 is super easy to debunk because we know the exact time, the exact date that they took that picture, so we can see that it's totally wrong.
And with the blue marble, we see the whole continent of Africa almost cloudless, and up from there you see Saudi Arabia, and right up from there on the horizon you see a little bit of Asia. And down at the bottom we see Antarctica and the South Pole.
Well, you know, at that exact time, there's a lot more that was in daylight at that exact time. So it's things like that. They had to be so careful on what they did because it's too easy to debunk, which all of NASA's stuff is falling apart because it's fake.
Why is NASA and the other space agencies showing us these images or fabricating these? They need to reinforce the heliocentric model. I mean, we are all born into this system with a globe in the classroom. We are spinning and orbiting and chasing the sun through the galaxy, and these other planets, other worlds that we potentially can land on. That all has to be reinforced over and over and over again. And so, you know, if we don't have pictures of the Earth from space with the technology that we have now, then, you know, the lie isn't going to last very long. So they continue to put these images in front of us to very simply to reinforce the model. If somebody's just starting their investigation of images of the Earth from space, then I would point them right to fakingspace.net, you know, season 1, episode 1, and going through some of the main images that we would get, that we have received from NASA of the Earth from space over the years, and showing how you can do the same analysis that I did by using free software tools, things like Forensically and photo editors, and looking at the levels. And that's what my series is all about, is showing that there's anything but real. Because they wouldn't need to fake it if it was real. They fake it because they have to.
Have him hit us again.
Alright, that is a weaker laser. Here comes a different color.
Right there. That is sweet. Can you zoom in? Pretty? It's a pretty laser.
Okay, flash your laser, Dan.
Give it to return if you can.
How's it over there? I mean, this is an ultra wide lens. I can't zoom in. Yeah, I got it. Oh yeah. That's very obvious. Yeah, I see it. Let me get that.
Scoot over. Oh yeah.
Can you do it again, Dan?
Yeah, let me see how.
Okay, one more time, a couple more times, Dan, please. There, you got it.
Yeah, that's it.
Yeah, there we go.
Yeah! That is a beautiful experiment.
That is totally cool.
At 18.8 miles and a laser height of 5 feet off of the water, according to the globe math, the globe horizon should have been closer than 2.7 miles away, and Robert would have had to have been at a minimum height of 173 feet to have seen my laser on the alleged globe.
This is Rendezvous Beach. That's where I am. Laser on the tripod. There it is. And I'm going to take a picture from exactly here, showing the GPS location.
Okay. I see your laser. I got it.
Okay. There it is. There it is. Oh yes. There it is. Yes. I can see it. And as he flashes at me, oh yeah, that's so bright with my unaided eye.
That's it. Flat Earth proven again. You can definitely see both the source of the laser and the laser's reflection on the very flat water. There's no possible way that the laser and its reflection jumped 173 feet over the Earth bulge to present a perfectly flat water. That's insanity. Giant bulges of Earth curvature simply do not disappear without a trace. Without question, Bear Lake has no curvature whatsoever, which belies the globe because you can't have a large body of water with no curvature.
You could see the city. I had the camera on it the whole way, and we're talking the whole way, and we're trying to figure out what's happening here. We get about 10 miles away from the city, and there was like this fog. I don't know, it had to be 100, 200 feet tall, fog that was obscuring the bottom of the city from our vantage point at about 10 miles out.
It was almost like smog.
From the distance, it was like this blue wall almost. Yeah. When you're inside it, it's a little bit hazy, but you don't really perceive that you're necessarily in this wall of fog. But when you pull back 50 miles to the other side, all of that gets compressed over the distance because the way the perspective works, right? Yeah. So that gets compressed, and then it blends in with the water itself. So that's the first thing I started thinking is, well, that's why part of the city is being obscured, is because you can't see that until you get there. But it wasn't accounting for all of it. I mean, we're missing a fair amount of the lower part of the city. So, of course, people who believe in the globe say, well, that's because of the curvature. It's hidden behind the curve, right? But you notice I said, if it's a mirage, right, the city's going to roll up over the ball, right? We're supposedly on a ball, which means we're traveling over a hump, supposedly. But I started thinking about the atmosphere and moisture. And what is moisture, right? It's zillions and zillions of microscopic balls of water acting like what? A convex lens. What is a convex lens? It's a magnifying glass. If the atmosphere, especially over water, is made up of zillions and zillions of tiny convex drops of water, then collectively, perhaps they all combine to make one big convex lens, in which case it would act like a magnifying glass. And so we noticed that even back when we got back from the trip, going back to the other side, the lower the sun got as it got closer to the sunset, everything started getting bigger and magnified, like really magnified. And what really caught my attention was there was a sailing ship that when I was at a sailboat, had a big sail. And it was probably, I'm going to guess, about a mile away from, there's like a little berm of rock or something there. And it was about a mile beyond that. And on my way to the airport, I think it was the next day, I was driving on the highway and I saw a car. It was sitting right next to me. We were kind of stuck in traffic. And so I'm looking at this car, and then behind the car is the Willis Tower. So I snap a picture just to get a scale. Here's the Willis Tower, here's a car, right? Yeah. And then I took the picture of the car and I isolated it in Photoshop and made just the car. And I slid the car over in Photoshop to be the right scale to the sailing ship. And said, okay, so here's this car and the sailing ship. The sailing ship is only a mile away from where I am, and I'm 46 miles away, so let's say 45 miles away from there. And there's the Willis Tower. And it actually looks bigger from 45 miles away than it did when I was sitting right next to the car looking at it. And I'm a mile, I was like at 1.26 miles.
Yeah, you were not even 2 miles away.
So that's when I started thinking about atmospheric magnification. The atmosphere is acting like a lens, which magnifies a city, brings it up a little closer, and as it does so, we start to lose a little bit of the bottom of the buildings, and perhaps due to the density in the atmosphere, there's additional refraction that takes place that makes it drop down even more. Is that what happened? Let's look at it from another angle here, from the side view. I'll bring our graphic back in of refraction. Let's go ahead and orient the graphic so it better represents what we're looking at here. I'll angle the light rays to show the density of the air here causing the refraction, and bring our lens in so we can magnify the city. It brings the city up, and as it does so, we start to lose a little bit of the bottom of the city, and perhaps either due to the magnification or due to additional refraction, maybe it is dropped down a little bit more, and this is what we end up with. Just like we saw. Now this is a still frame from the half-hour video that I did, and the numbers you see there are all based on the numbers that Tony was giving me based on his device. His device said it was 37 nautical miles, which is 42.6 statute miles, but when you plot the same exact location that we were at, the exact distance you get on Google Earth is 46 miles. So you basically add about 4 miles to all the numbers that you saw in the half-hour video. And what's funny is, while we were doing our test, the weatherman actually had to retract his original statement. It was a year. It was like, I think it was a year to the day. He got nailed by probably a lot of flat earthers. You know, he's like, well, you know, we got a whole lot of email from my
viewers. Chief Meteorologist Tom Coombs here, and I want to talk about mirage. I thought it wasn't that big of a deal when I shared this picture about a year ago from Joshua Nowicki. You could see the entire Chicago skyline all the way down to almost the shore of Chicago from the shores of Lake Michigan. Something I said was impossible, at least under normal conditions. This had to be a mirage or some sort of focusing by the atmosphere because there was a big inversion that night. Thought it was pretty straightforward. Did a quick 30-second explainer on air and moved on with my weathercast. Well, email after email later, this is just a few of those emails, Facebook posts, comments. I was shocked to find out that there are a number of people that believe the Earth is still flat, and that to them, this is actually proof that the Earth is flat.
So he goes to some expert on optics or whatever.
Yeah,
and
at Notre Dame. He went to a professor at Notre Dame.
So he was trying to say, well, so miraging isn't really the correct term, right?
The word mirage originates from the same root word as the word mirror. So technically, I think if you're going to be a stickler about it, you would say a mirage has to have an inverted image.
Right, so he's like, well, looming would be a better term.
That picture from a year ago, that's looming.
Looming is defined by the dictionary.com website as a mirage in which objects below the horizon seem to be raised above their true positions, and also to appear indistinctly coming into view in indistinct and enlarged form. Well, the indistinct part's tripping me up here because everything was very distinct. I mean, straight lines, perfect. You know, so I'm not really convinced that we're really necessarily dealing with the dictionary description of looming. So you look into looming and it, you know, it's magnification and stuff like that. But as I started thinking about the atmosphere acting like a magnifying glass, I went to Walmart and I got a 8.5 by 11 magnification sheet you would use for like reading or something, right? So I get this magnification sheet and I make a cutout of the city. And I put the magnification sheet in front of the city. The city, city's here, magnification sheet here. And I took my cell phone and put it on the other side, and I looked at it, through the lens, so I could see the entire city. And then on a flat table, like as if the iPhone is the boat, I backed it up. And as I backed it up, the lower part of the city disappeared. Using the sheet right here, set the city up, a little cutout of the city, and now I've got the big magnifying glass sheet. Bring the camera right up to the lens. See, that's the normal view of the city. Now let's back up again.
The science is the same of that of a lens. Here's a simple example.
So if you're looking at Chicago here,
the atmosphere really is acting like a lens.
Yes.
Atmosphere really is acting like a lens, and this is how much of the city is missing due to the lensing effect, the magnification of the atmosphere. You're missing a good portion of the city just by pulling my iPhone back on a 3-foot long desk. That's how much I lost of the city. So I could replicate exactly what we could see from the other side of the lake. I could replicate on a 3-foot flat table. Science is supposed to be testable, repeatable, observable, stuff, right? Well, this was the easiest thing. Yeah. It's like we had the experts now. That. But no, he actually said, so the atmosphere acts like a lens, right?
Yes.
So the atmosphere really is acting like a lens.
Yes.
And then he put a lens in front of the camera. But they were doing the reverse. They had the city down low, put the camera, the lens in front of it to make the city jump up.
So if you're looking at Chicago here, just maybe now you can just see the top of the Sears Tower, and if our simulated temperature inversion moves into place, hopefully now you can see pretty much all of Chicago,
see all the lower buildings,
including what's at ground level.
Right.
I'm saying no, refraction bends the light down. I went to all these websites that show refraction bends the light downwards. Let's look up some websites dealing with the refraction of light. You might see a graphic something like this, showing light bending downward, just like the weatherman guy said.
What's happening is the light from Chicago is being bent by the cold air above Lake Michigan slightly downwards towards the observer here in Michigan, and that's helping the light rays get around the curvature of the Earth, so to speak, so that Chicago can be seen almost all the way down to ground level.
But they have sort of an unusual, although I would say very common, view as to how downward refraction is being used to allow us to see things up, over, and around the curve.
So like if refraction's bending the light downward, then just normal refraction over a distance, of a medium of, let's say, water, which is what the atmosphere over water is.
Yeah.
Atmosphere is water anyway, but even more so over, a lake bed or something. It would lower it. So
it was selective science that they did.
Very much so.
That's what it was.
They actually proved our point.
Yeah.
Without realizing that they did.
What is the biggest obstacle for scientists to investigate the flat Earth? Conformity, the intellectual conformity that is forced upon all of the scientists and all the intellectuals, that they think that to be smart, you have to follow the crowd. And it's not that way. To be truly smart, you have to learn to think outside the box. Flat Earth is the ultimate thinking outside the box because it opens up so many more questions and ideas. Flat Earth says, ask those questions again. What is the sun? What is the moon? How far away are they? Is there a way we can determine it? All those questions are now open. So Flat Earth is intellectual freedom. I welcome all PhDs, physicists, scientists, everybody to come and investigate. Look at it with an objective and independent mind. You will see that at the very least, that there's substance to it.
Everything that comes out of that TV is programming. It's scripted. They report a narrative of what to believe. And if people like me and you, simply by questioning the validity of it, we're ridiculed. We're called a conspiracy theorist.
I'm sorry to cut you off. I only have a minute and a half, and I don't really need to hear what you're trying to provide. I want to know how you're dealing with all these conspiracy theorists on your platform.
So the first way is by demoting low-quality content and promoting more authoritative content, and the second is by providing more transparency for users, such as searching for "the Earth is flat" on YouTube, where you see a lot of...
Your response is to put a box saying, nope, the Earth is not flat.
Correct.
That we cannot question what they tell us.
You can't stop me. You can't stop me. You can't stop me. Can't stop me.